Hi, everyone, and welcome. Good afternoon. Thank you guys for joining us today for our 30-minute lunch and learn. I'm Dena Filiaggi. I run Ark Technology's Southeast region, supporting healthcare, life science, legal organizations across the Carolina, and I'm really thrilled you all are here. We know how busy IT and security teams are this time of year, so our goal today is simple: give you a clear, practical look at how Ark is taking a modern preventative approach to endpoint protection, really strengthening security without adding more tools, noise, or complexity. I'm joined by our cybersecurity architect, Hunter Clark, who will be providing a full live demo and walking through how organizations are reducing gaps and preventing lateral movement. This session is being recorded, and I'm happy to share the recording afterwards as well. Of course, please reach out to me directly if you have any additional questions after the event. We want this to be interactive, so feel free to drop questions in the chat as we go, and we'll save time at the end if we have for Q&A. So without further ado, we'll jump in and I will hand it over to Hunter.
All right, thank you, Dena. So real quick, just to give you high level what we'll work through, there's a couple of slides to talk through the solution and how we're taking more of a proactive approach to securing organizations. A couple slides here, and then like Dena said, I'll jump right into the demo. So this slide here is really meant to highlight the difference between typical EDR detection and response approach versus more of the modern, more of a zero trust approach to endpoint protection. So you can see here, I've called out some of the different types of things that might be going on the endpoint. So there's viruses, ransomware, there's remote access tools that threat actors are using, and then obviously with AI, threat actors are able to generate brand new malware that's never been seen before. So if you think about how these EDRs are having to function on the endpoint, they're really having to make a judgment call each time there's a process that gets kicked off to, they're going to determine, is this something that is malicious, where it's a known malicious file that's already out there? Is this a legitimate IT tool? Like, is it PowerShell and it's being used in a malicious way? Or is it, a remote access tool out there? Or is it something that we've never even seen before? So as you can imagine, it really puts a big burden on the EDR there. And like I said, with the rise of AI generated malware, it's really not going to be very effective in the long run for securing the endpoint. So you might catch 99.99% of all of the malicious activity on the endpoint, but you have to be right 100% of the time, and the threat actor really only has to be right one time in order to get into your environment. So here, kind of to highlight the difference between what we're going to talk about today and some of the other solutions. So a lot of the tools that you see in that detective and corrective area of the little chart there are tools that you've seen before. So CrowdStrike, Defender, SentinelOne, these are all tools that you probably have heard of or probably have in your environment to some extent. And those tools are incredibly great at what they do, which is detecting malicious activity, known malicious activity, and then correcting it by isolating the device, maybe disabling a user account, or killing a process, but returning the endpoint state to a normal state after the detection. However, kind of where we fit in and where we're trying to help organizations get to is more of that preventative approach. So instead of having to worry about detecting every brand new ransomware variant that comes out, every new tactic or technique that threat actors are using, all of the new tools, and hoping that your EDR is able to detect those, we like to try to get ahead of all of that and build more of a preventative, basically put a box around the endpoint and say, these are the exact applications that are allowed to run. And then even from there, determine, even when those applications are running, what exactly are they allowed to do? So we really feel like getting ahead of the threat actor and implementing more of this preventative approach is the best path forward in the long run for organizations. So from there, I will just jump over to kind of show you how exactly we do that for organizations. So This here is the portal. We leverage a tool called ThreatLocker to help organizations with this. But at the end of the day, this solution is an agent that gets deployed out to all of your endpoints in your environment. There's multiple ways to get this rolled out. There's PowerShell scripts. There's MSI, EXE. Basically, if you have a way that you typically deploy apps, you can leverage some of the methods here to get that deployed out. So whenever the agent first gets deployed, it's going to start out in this application control learning mode. And what that's going to do is baseline the device. It's going to scan the hard drive, figure out, okay, what does this user already have on the machine? And it's going to start automatically building out these application control policies here as to what those applications are. So under this application control, you can see here some of these have a created date. And these would be the standard. If you've ever done any application allow listing before, you've probably seen something like this where you can permit, based on the hash of the file, or maybe even if the application's signed, you could permit based on, the path. So if it's under a certain directory and it's signed by this organization, that's something that we would trust and allow to run. However, as you can imagine, not all companies sign the files associated with the application. So what really separates, this solution that we help organizations implement from other allow listing solutions out there are these applications that you see here with the check mark. So with these applications, instead of you having to learn the app and then figure out, okay, if an update comes out and the hash changes, is it going to break the app? Or are we going to, have to worry about patches getting rolled out that stop the applications from working because we don't have the right rules associated? With these, you really don't have to worry about that. There's over 10,000 of these now, where what ThreatLocker is doing on the back end is they're monitoring these vendor sites closely and even trying to work with the vendors if they'll allow it to maybe get early releases and ultimately just catalog all of the associated files that make up that application. So you can see here, even if I click into one of these that has the check mark beside it, I can't actually see the application files that are associated with it. And that's because it's something that ThreatLocker is keeping up to date for us. So really all I have to do here is just say, okay, who in the environment is allowed to run this specific application? So think of this page here as just the definitions of those applications. And then if I click over to policies, you'll see that this is where those actually get applied across your organization. So now you can see here, maybe there's an application that we want to block across the organization, not necessarily for security reasons, but maybe for productivity reasons for the end user and also for IT. So maybe if you wanted to standardize on everyone in the organization should be using Microsoft Edge, for example, you could create policies like this that block all other browsers, so that way users are kind of forced down the path of using the organization-approved application in the environment. But beyond that, there's also permit policies, obviously, and these policies can be applied at multiple levels. So you can have them like this, where it's all policies, but traditionally it would be you could apply across the entire org. You can apply it to a specific machine, or you can apply it to a specific computer group. So if you had a group of machines, like maybe an accounting department or developers that all need the same standardized application set, you can create a group for those computers and then only permit these applications for that group. So not everyone in the environment needs to run Visual Studio Code, for example, or maybe not everyone needs to run Wireshark. You can get granular as to who exactly is allowed to run those applications. So 99% of this is done automatically. We will have to, create some custom rules potentially, but most of this is done relatively automatic. And then, so through the application control mode there, you can also build out, like I said before, exactly what these apps are allowed to do when they're actually running. So if I click into, the example I always like to use is PowerShell. So if I go over to PowerShell and I open that up, we can see here within these policies, this applies to only the devices in my administrators group. What actually, from that application control tab I showed you earlier, what actually is associated to this policy. But then here we can permit these apps with what they call ring fencing. So here, maybe we trust PowerShell to run, but there's really no reason that it should be interacting with other applications like BitLocker or Internet Explorer. Maybe we want to restrict it so it can't interact with files that are in the environment. So maybe there's certain sensitive file paths. And then also we can restrict it from calling out to the internet. So unless we create an exclusion to allow that to happen. Going down a little further, there's also a toggle here that makes it incredibly easy where if you had an initiative as an organization to start removing local admin rights from users, ThreatLocker can help out with that by making it where these policies elevate the user permissions to run specific applications as an administrator. So instead of you having to log in as IT with an admin account and get something installed for the end user, or instead of having to give the end user temporary local admin permissions, you can use this here to just elevate the user only whenever they need to run that specific application, and then only for running that specific application. So if we elevate for PowerShell, the user can't elevate, command prompt or other applications, only the ones that we decide on there. So then from there, if you think about the timeline, how this kind of helps prevent a breach in the organization, obviously with the application control piece, we're going to block everything across, that's out there unless we have a policy that permits it. This is a deny by default solution. So at the end of all of these, they get processed like firewall rules. At the very end of these, there's that default deny where we're going to block anything that we have not created a policy to explicitly allow in the environment. From there, it typically takes only about 21 days to take a device from that learning mode into the secure mode. From there, it's a matter of approving applications that an end user would like to request. So the solution, incredibly user-friendly. If I were to flip over to, an example here, if I wanted to run Brave browser, for example, and we don't have a policy to allow it, I'll receive a pop-up, and this can be fully customized if you wanted your company logo, if you wanted to change the wording. But then from there, as the end user, I would click request access and say, I need this for, whatever the business reason is. As to why I actually need this application on my device, I can include an email address if I want to receive an email based on what the IT team decides. But then from there, send request, and then your IT team or your security team, whoever's ultimately managing the solution, will receive a notification. It could be through a text message. It could be an email. You can receive a push notification to your phone with their mobile app. But then from there, you'll be able to come in, see that there's a request, and then get some information on what exactly was requested. So here I can see the path. I can see, okay, is it signed? What the user's reasoning is for needing this application in the environment. There's a direct integration with VirusTotal where I can run it through VirusTotal to see if it is a known malicious file. And then the other thing you can do is run it in a sandbox that's provided for you as part of the solution. So instead of approving it based on that, you can run it in this temporary sandbox VM that's spun up in ThreatLocker's environment to see what the behavior of the application actually is. So if I wanted to see, what actually is this, just because it says it's something doesn't necessarily mean it is, or doesn't mean it's not doing something malicious in the background. So here you can see the application's running. There are canary files on this VM, so if the application is designed to look for credit data, it'll flag up here if that was something that the application tried to interact with. It's looking at network traffic to see is there malicious network traffic that's being sent out. And then the other nice thing is you don't always realize this, but there's a vast number of files that get included as part of just a standard installation of an application. So here you can see all of these DLLs and EXEs that are getting loaded in the background as just part of that one application. All of these are ran through VirusTotal as well, just to validate if, just to make sure that there's not something malicious that's getting loaded in the background that's a known malicious file. So those would all get flagged in the VirusTotal section if there was something that was flagged there. So the sandbox environment's great, especially for things like PowerShell scripts, or applications that you can't really tell 100% what this is, and you want to make sure it's not something malicious before you approve it across your organization. So then from there, like I said, there's over 10,000 of these built-in applications that are managed by ThreatLocker. So here I can just choose the Brave browser built-in. Then you can choose, okay, who in the environment is allowed to run this application? Is it this computer? Is it all of my workstations? Or maybe the entire organization is allowed to run it. You can set a policy expiration. So maybe you have a vendor on site and they need an application temporarily for a week or a few days or a few hours, and you don't want to make that a permanent policy. You can choose the policy expiration there. From there, there's ring fencing, like I mentioned. You can build your own ring fencing rules, but for some applications like browsers or some of these commonly exploited applications, ThreatLocker has suggested ring fencing, which will restrict it from interacting with things like command prompt, PowerShell, things that are outside of the typical behavior of, in this case, a web browser. And then, like I said, if this is an application that requires those local admin rights, you can choose to have it automatically elevate the user permissions to run this specific application as an admin, and then make that a temporary thing so that it's not always permitted. All right, so then from there, you just click submit approval, and then the agents check in every 60 seconds. And so from the end user side, the next time that the agent checked in, there'd be a pop-up that let the end user know that there was, that your application has either been approved or that it's been rejected. So from there, moving on, that's at its core. That's ultimately the core of how this solution is helping organizations be a little more proactive in the environment, restricting everything down so at the end of the day, these are the exact set of applications that are allowed to run, and you don't have to worry about someone makes a LinkedIn post about how there's some brand new ransomware variant coming out, and you're having to scramble around wondering if your antivirus is up to date. You would know at the end of the day, these are the set of applications that are allowed to run on my endpoint. And beyond that, there's nothing else that's permitted to run. So then from there, you can just start building controls around those applications in your environment. A couple of other things I'll touch on really quick. So network control, at the end, this is really just a host-based firewall, but you can leverage the fact that your devices are in ThreatLocker to build out policies such as, I'm gonna go to like my servers. Maybe I want to, or maybe your insurance company is telling you, hey, we don't want you allowing web traffic outbound from your servers. So simple enough, like I said, agent checks in every 60 seconds. So within 60 seconds, you could create a policy that blocks all outbound 443 and 80 traffic on your servers. And then you probably would want to, before just blocking it all, we would work with you to make sure that we're not going to block something that's a legitimate need or an application dependency. But from there, you can also block things like inbound RDP traffic across, any source, any IP address that tries to communicate to your servers over 3389. You can block it here and then create an exclusion to say, but we want to allow our admin users to be able to RDP into our servers for maintenance or whatever reason they have. So really from there, like I said, ThreatLocker gets in your environment, and let's say they get on just a standard workstation. That's not going to be something that you would permit ideally to RDP into your servers. So it starts to kind of contain the threat actor even once they're on a device, so that way they can't move laterally within the environment there. Next one, storage control, touch on this one. So whenever you enable this, the first thing it's going to start doing is looking at some of these default locations here. So it's looking at any USB interactions. It's looking at network file access. It's looking at local folders to see, it's looking at the documents. It's looking at the desktop to see if there's any read, write, move, delete of files that's happening there. But you can obviously add your own paths. And as you saw, you can get pretty granular with this as to determine it has to be a certain file path, it has to be a specific device, which the devices are approved by the serial number. So leveraging this, you could theoretically have a list of known good storage devices based on the serial number that you approved for the organization. And then across the org, create a policy like this that says, I want to block all USB file interactions. But you can still, again, allow the end user to request. So instead of just, being the department of no, we like, to give the user the ability to request this behavior whenever there's actually a business reason for it. So then above that, we would have your approved policy. So here we could say, yes, you can use USBs, but only if it's a USB with this serial number and only if it's a PowerPoint or docx file. You can even get as granular saying it has to be a specific program that's interacting with that file path. So if you had, backup software like Veeam, or maybe you're using FSLogix to manage user profiles, you could create it where the only application that's allowed to read or write to that path is, fslogix.exe or veeam.exe for your backups. So again, for the end user, if I wanted to, one second, if I was an end user and I wanted to create let's say a text document on this USB drive, as I said, just to show you, this is what the end user experience would be like. So I tried to do something that's out of bounds of what the standard is for the organization, and I'll get this pop-up here that will allow the user to request access to that to perform that behavior. All right, so storage control, ThreatLocker Detect is, think of this as an EDR, but as you can imagine, it's not an EDR in the sense of how most EDRs are, where they're having to determine like good, bad files. This is more so built around, behaviors in a way. So if someone's doing something like port scanning, or maybe someone created a domain admin account or cleared event logs, there's, a whole host of things that you can create here based on all of that data that's being pulled into the portal. So if you had storage control and then detect, and let's say you're worried about DLP. So what you could do here is create a policy that says, hey, if the action type matches move and it happens, I don't know, let's say 10 times within, 1 minute. So maybe that's a sign that someone in your environment is, they're moving a lot of files, and typically that's not something that users should be doing. So this could be a sign that someone's trying to exfil data out of your environment. So you can build out policies like this, leveraging all that data, and then say what action you want to have take place. So maybe you just want to create an alert. Maybe you want to enable or disable another policy that's in the environment. Maybe you want to initiate a defender scan, isolate the device, kill the matching process, or just take no action. Maybe you just want to log it so that way you can review it later. So basically, if there's detections that you're like, man, I really wish our endpoint detection tool could do this, or I wish I could create my own detections, this is something, this solution here would allow you to do that, leveraging, as you can imagine, all of that data from file interactions to applications that are executing to network control, where you're seeing just traffic in the environment. You can leverage all this data to build your own custom detections if there's not one already that you want to see. Just to show you, there's obviously way more than just the ones I showed you there. If I came into the community and went to endpoint detect, there's hundreds of apps or detections that are already there in the background that you don't have to worry about creating, and these are all mapped to MITRE for the most part. So you can it's not only those 5 that I was showing there. This does extend to M365. So there's a connector that will ingest Microsoft logs. So if you wanted to get alerts on risky sign-ins, or if you wanted to see alerts around impossible travel time, and then from this one console isolate or disable a user account, that's something that you can do as well with the M365 detect piece. And then the last thing I'll mention on these two is there is a 24/7 MDR service. So if you wanted someone monitoring those alerts and taking action based on a runbook that we create, that is definitely something that is possible. And then the last one here I'll touch on is web control. So this is just basic content filtering based on these categories. So if you wanted to block gambling sites, explicit content, maybe LLMs and AI tools, that is one of the categories. So if you're trying to start restricting users' use of AI, obviously with application control, you're going to block it from getting installed in the first place. But then leveraging the web control, we could start blocking users trying to get to LLM and AI sites, and then maybe make exclusions based on what your organization is willing to allow users to do. So yeah, that's a quick overview of all the modules. At the end of the day, the solution is really built around just giving you that full control of the endpoint. And again, with that deny by default approach to it, where we're just going to block we're going to block everything and just only permit by exception exactly what needs to happen in the environment. So again, it allows you to be more proactive. And allows you to get ahead of the threat actors, so you don't have to worry about all of the new techniques that they're using.
Awesome. Thanks, Hunter.
No problem.
We did have a question come in as well. What operating systems does ThreatLocker support, and are there any limitations we should be aware of?
Yeah, so ThreatLocker supports Windows 10, Windows 11, Windows Server. It also supports Mac OS, and there are some Linux distributions that it supports. So like Red Hat Linux, Ubuntu, so some of those common ones there. You might have seen there is this mobile device tab here. It's actually not for actual like allow listing on mobile devices. It's more so for a different module. But the only supported operating systems are Windows, Mac, and some Linux.
And one more. What does rollout look like, and how long does it take to kind of be fully functional?
Yeah, so we typically start with, we like for people to start with a POC, right? We want to make sure that the solution is a fit for your environment. So we would work with you and meet for about an hour. Typically, we would deploy to 10 to 20 machines. And from there, we'd start building out some of those policies, based on what's running in the environment. It typically takes 21 days, sometimes less, in order for a device to go from that learning mode into secure mode. 21 days is typically a good measure to give the user time to use applications that might not have been caught in that baselining. But from the POC, we're building out these policies, in your live tenant. So if you decided that this was a solution that was good for you and that you wanted to implement, we could just easily roll it over. It's the same portal, it's the same policies we create. So we're really basically building like an early stage production instance of ThreatLocker for you. So that way, when you go to add 100 more devices, we already have a lot of the policies for what should be running at that group level. So the learning mode just over time continues to drop because we already have these policies here for the common apps for your environment. I saw another one from Oliver. Is ThreatLocker a lightweight application? What type of demand would it have on network resources, capacity, et cetera? So at the end of it, it's really a very lightweight solution. It's just an agent deployed out to each endpoint. The only time you would notice any resource utilization, to be honest, is that baselining period. That's when it would be at its peak, and that's because it's scanning the entire hard drive to start building out these applications for you. After the baselining, CPU is basically nothing, to be honest, and then memory hovers between 200 and 600 megabytes is the standard of where the memory will sit. But we've deployed this across tens of thousands of endpoints, and I can't think of one time that has brought to our attention that there was a resource utilization issue caused by the agent. All right.
Perfect. Well, we're right here up on time. If anybody has any other questions, please feel free to reach out to me. I will touch base with each of you as well after. Hopefully you all enjoyed your lunch and the session, and we really appreciate your time. Thank you, Hunter.
Yep. Thank you, everybody.